So now when you're naming ionic compounds based on you have their formula and you want to figure out what their name is, for binary ionic compounds, that binary just means there's only two elements. The main rule you're going to do is you're going to put the metal or the cation, it's written first in the name. It's also written first in the formula, so it shouldn't be hard to figure out which one goes first. The name of the element for your cation does not change. So if I look it up and it's Pb, I know that I can find Pb, and I just write the name of Pb, which is lead, and I just write lead. That's all I have to do for that so far. Your group A metals, so anything with an American numbering system of A behind it, or any metal with only one charge like silver with a +1 and zinc with a +2, you don't have to put a Roman numeral behind that metal's name because you know the charge based on looking at where they are on the periodic table, or they're always going to have those same charges. So you don't need a Roman numeral to specify the charge. The rest of your transition metals and other metals with multiple charges like those in group 14 or 4A, they require a Roman numeral to indicate which charge of ion was used. So you can find the charge by crossing up your subscripts and checking the negative, and then seeing what the charge is, and then putting the charge as a Roman numeral behind the name. Your nonmetal anion is written second in the name, so you change the suffix of the ending of that element to "ide". So if I had iodine, I would switch it to iodide. If I had oxygen, I would switch it to oxide. If it was nitrogen, I would switch it to nitride. So the only one that you switch the ending of the name is the anion that's negatively charged nonmetal there. So some examples of ionic naming. If you have a metal with only one charge, either it's in your A group element or you know it's a charge like zinc and silver, you just put the name of, if I have LiBr, I look up Li, that's lithium, and I look up Br, that's bromine. I switch the ending of the second element to ide, and so I just have lithium bromide for the name of that element or that compound. If you have a metal with multiple charges, for example, if I had CuCl, this is copper. I don't always know the charge of copper or Cu, but I can look at chlorine, and I have one chlorine. Chlorine is a -1 charge, so if chlorine has a -1 charge, and there's only one of each, to have an overall net charge of 0, that must mean copper is also a +1 charge. So I would put copper, Roman numeral 1, copper 1, chloride, switch the ending of chlorine to ide there. And the second one, I would look at my negative to figure out the charge of copper. Chlorine, there are two chlorines. Chlorine is still a -1 charge. If I have a -1 charge for chlorine and there are two of them, that must mean my overall charge here is a -2. If my overall charge here is a -2, then my copper, to cancel that out, must be a +2. So then I have copper 2, and then I switch the ending of chlorine there to ide. If you have compounds containing a polyatomic ion, remember you find those on the back of your periodic table in your polyatomic ion chart. Most of them are anions, so they're going to come second in the name. If you recognize them, you can usually see if you have more than 3 elements or capital letters in a compound, for an ionic compound, then you know that you're going to have a polyatomic ion in there. So if you have more than 3 capital letters in your compound, if you look at it like down here, I have P, C, and O. Those are 3 capital letters or capital compound element letters in that name in the formula. Then I know that I need to look into my polyatomic table and find which one is a polyatomic ion from there. Sometimes it's easy to spot because they have parentheses around them. Then you know right away I'm looking for CO3, like this one down in the bottom. Here's some examples. They're all in the back. Keep the entire polyatomic ion with all its subscripts in the formula, and you can't leave off the subscript. CO3 does not equal CO. So remember, if you have more than one polyatomic ion needed, you have to place the polyatomic ion in parentheses with the subscript outside. When you're naming them, most of them have a suffix or ending of "ite" or "ate". Do not change the suffix of the polyatomic ion. I'm going to leave it as lead for carbonate. I don't change the ending of my name there. So if I look back at my last slide, I had lead. I don't know the charge of lead all the time, but I can see that I knew it was a +4 charge based on my looking at my charges here. CO3 is a -2. I have 2 CO3s. 2 CO3s at a -2. That means I have a total overall charge of -4. So my lead, to cancel out that overall -4, must be a +4. So that's how I get my charge there. So when I have my name, I have lead 4 carbonate. Don't change the ending of your polyatomic ion's name. So more ionic naming examples. If I have KCl, that would be potassium chloride, KCl. PbO, I look up Pb, that is lead. I don't know the charge of lead all the time. So I look up my second one, that's oxygen, O. It's a -2 charge. So to cancel out that -2, my lead must be a +2. I have NaNO2, 3 capital letters here, so I know that one of them is probably a polyatomic ion. I can see that NO2 is nitrite. Notice I didn't change the ending of that name. I didn't switch the ending of my polyatomic ion to "ide." You always leave them exactly the way they are. You leave them the same. You put parentheses around them when you're doing your formula, and you leave their name alone. So I have NaNO2, sodium nitrite, copper 1 sulfate. So here I need to look, SO4 is sulfate. It has a charge of -2. I only have 1 sulfate. So in order to have 1 sulfate at a -2 charge, I have an overall charge of -2. On my copper side, I have 2 of them. So whatever my charge is would be divided by 2, my overall charge. So if I have a -2 on this side and I have 2 coppers, each copper is probably going to be +1. And I can double check if I had copper +1, copper +1, add that together. That would be an overall charge of +2 to cancel out my overall charge of -2. Another thing you can do is cross your subscript back up and across. And remember, my SO4 stays together as 1 here. So I would have a -2 on my SO4 and a +1 on my copper coming from crossing up my subscripts back to where they were before. Opposite of when you cross them down to find your subscripts, you cross them back up to find your charges if you ever need to. And then check to make sure your negative is correct so you know it hasn't been reduced. Down here, NH4, again I have 3 capitals, so NH4 is going to be ammonium. I leave the name the same there. That subscript is telling me that it's ammonium. It's not telling me that I have 4 hydrogens here. I mean, that I do have 4 hydrogens here, but it's not telling me that that's separate. NH4 is ammonium. And then I have chlorine here. Switch the ending to "ide." So first you need to make sure the metal has 1 set charge. If it has multiple charges, you have to find what its charge is in that compound and write it as a Roman numeral behind its name. If you have 2 elements total, then your second one you're going to end in "ide." If there are more than 2, then you know that one of them is going to be a polyatomic ion. So you look up that polyatomic ion and you leave the polyatomic ion's name the same.